Sample. Okay, so let's read through this document. So it's look for the trace. I think it's 2.3. Yeah, here it is, 2.3 task 1.3. So this is the problem that we're going to solve as part of the assignment. I'll modify the Word doc. But essentially, so what do you have to do for your assignment related to Scapy is you need to complete the Word doc that I just did, all those steps, and then we need to solve this problem. And I may add a second problem on Thursday or Wednesday. So let's think about this one. So the objective of this task is to use Scapy to estimate the distance in terms of number of routers between your VM and a selected destination. This is basically what is implemented by the Traceroute tool. In this task, we will write our own tool. The idea is quite straightforward. Just send a packet, any type, to the destination with its time to live TTL field set to 1 first. This packet will be dropped by the first router, which will send us an ICMP error message telling us that the time to live has exceeded. This is how we get the IP address of the first router. Make sense? So that's the idea. We will repeat this procedure until our packet finally reaches the destination. It should be noted that this experiment only gets an estimated result because in theory, not all these packets take the same route, but in practice, they may within a short period of time. The code in the following example shows one round in the procedure, okay? If you're an experienced Python programmer, which all of you are, you can write your tool to perform the entire procedure automatically, okay? If you're new to Python programming, you can do it manually, changing the TTL field in each round and record the IP address based on your observation from something like Wireshark. Either way is acceptable as long as you get the result, right? So we're going to build this together, all right? But you guys get the idea, right? What we're trying to build, Traceroute. So then you get the essential thing about changing the TTL, and we want to get those IP addresses. So we are in NAT mode, so I don't know if we have to be in bridge mode. That's one thing that we have to think about. We may, but so let's try it. So here it gives us a very basic example. We create a packet. See, I'm looking at this, right? So it gives us, we create an IP packet. It's going to be ICMP. We set the destination IP to whatever we want it to be. We can start with Google's DNS server. And then we set the TTL, right? And we're just going to modify that manually and send out the packet. So let's try that. So I'm going to start the terminal. -L, cd desktop, clear, -L, cd its 372, spring 2025, clear, -L, cd network Scapy, clear. Okay, so we're going to create the script here. So I'm going to do nano. I'm going to call it my trace route.py, right? So the library from Scapy, all from Scapy, import all. Okay. So let's think of the logic. So let's say how many hops, so number hops. Like a maximum, that's what I mean. So no more than 25 hops. All right. So now the mechanism is basically to send out packets, right? Where TTL is increasing essentially. So for I in range, um, one, two, number of hops. Okay, one, two, three, four. Okay, so we're going to create a packet, PKT, KT. And let's just define it as a function. So I'm going to say my packet, and we're going to pass to this I, which will be the TTL. So if you notice, it starts at 1, 2, 3, 4. That's what the problem's set to do. Okay. And then send packet, essentially. Right? So now we just have to define the function my packet. So I'm going to do define my packet, just like that. And my packet actually takes in a parameter. I'm going to call it my TTL. 1, 2, 3, 4. All right, so now I'm going to create the packet. So A equal IP. All right. Then A dot DST, and it's just going to be Google. So 8.8.8. Then I'm going to do now the TTL. So A dot TTL is going to be equal to my TTL, which is the thing we're changing, right? And hopefully we'll get responses from all the different servers. So then I'm going to do B equal ICMP. And now I can put it together as A, B. And this just returns the actual packet that I'm crafting every time. Does this make sense, guys? This should be the logic, okay? Now, getting it to work, as I said, we have to work on that part. And I think, if I remember correctly, we may need to be in bridge mode. You may need to try this at home, etc. But we'll see how it works. I'm just going to do Control X, Y, Enter. So let me see what happens. Let's see what happens. So I'm going to need sudo here and Python. Okay. And IP is not defined. Okay. Oh yeah, sorry. From Scapy dot import. Okay. That's what we've been using. Try it again. Clear. See what happens. All right, so this sent out the packets. So now, yes, doing it. Now we need a way of collecting the data. You guys see that? So obviously this is sending out packets. We're going to get responses back. So what's a good way of doing that? Hmm? Yeah, but in this case, this is only sending out packets. So we need something else to capture responses. You see what I'm saying? So I'm going to have, going to think about that. So I'm going to try. sudo Scapy. And then what was it? Sniff? Do you guys remember if it was just sniff? This is sniffing, right? So let's try it again. All right. So I'm going to try the script and see if I capture. Let's do clear here. All right. So I'm going to run my traceroute example. All right. It sent out all those packets. And this did not capture anything. Yeah, no, I'm trying to think. So if you guys can help me, that's great. I mean, let's solve it together. I'm gonna go to the document. So we've written one part of it, right? Which is the part that sends out the traffic. But we need to capture the responses somehow. That's why we may there's the sniff and spoof part of it too. Which sniff and spoof. But let me have it. The thing is, the problem is there's a time issue, right? Like they're not coordinated. One is sending out things, it's going into the network. We're getting packets coming back at different. So I'm trying to do this in two separate things here. Yeah, so I'm going to copy this sniff one. See if that helps. This has no filter, essentially. And if we're going to continue this on, because it's almost time, we're going to continue this on Wednesday, but the goal is to solve this as a problem. All right, so, yeah. Not this interface, but ENP 0S3. Okay, so it's listening now. So let's try it again. And like I said, one thing that I don't remember if it needs to be in bridge. Okay, so it's sending out the traffic. Okay, got some responses, it seems here. Or we got maybe just what we sent out, right? So that's the other thing. So we have to look here and see what we're getting. If I look at all these IPs, is 8.8 and 10.02. So, oh, wait a minute. Do you guys see that? That 149? Okay. Do you guys get the idea now? So you see we did get something, right? So 8.8.8 might be the final one. Hopefully that 149 is a intermediate. We can probably tell, so all right, so we have something there. Another 149, 11. So these two are different IPs. Do you see that? One ends with 11, one ends with 93. So some progress, right? So we are able to get some traffic. So we'll continue this problem on Wednesday and just refine it essentially. And hopefully we can make it a little bit more similar to Traceroute. Does this make sense, guys? And I'll think of one or two more problems, probably, and that'll be your homework. So your homework assignment for this week, we're done with Scapy, as I said. So now you know how to sniff and spoof network packets from the network using this library. So your assignment this week will be, of course, to complete this document here, and then I will add the traceroute problem, which is already added in there, I should say. It's this one here, but I'll add one or more. So we can practice a little. All right, so this is a good stopping point. So I will stop the recording here.